This is Module 2, Lesson 8, Sequencing Reflections and Translations. Today we're going to perform reflections followed by a translation, and then we're going to do a translation followed by a reflection, and we're going to examine those two types of sequences. So when we did translations, it was very clear when we translated along a vector that we could undo that translation by just moving the figure in the opposite direction, which would be the inverse transformation. Inverse is opposite. But not all transformations can be undone. So we're going to look at a sequence of reflections. So let's look at the following diagram. And we have line L, so let there be a reflection across line L. What would undo this action? What's the inverse of that transformation? Well, it would be a reflection in the other direction. Looking at this diagram here, line L is the line of reflection. And we have point P, and we have point Q on the line, and we have point A. This picture shows what happens when you reflect those images. So if you reflect point P across L, you get P prime. If you reflect A across line L, you get A prime. If you reflect line L, it's the same line, it's itself. If you reflect Q, since Q is on the line of reflection, Q, the reflection of Q is Q prime, which is still itself. So a reflection of point P followed by a reflection of P prime, kind of doing the inverse reflection. You're reflecting back to the original image, which is the identity. The identity is itself. We learned about the identity property in mathematics. The identity property means that the number doesn't change. 3 times 1 is still 3. 3 plus 0 is still 3. If you reflect P across the line and then reflect it back again, you have P again. So this is just showing you that if you reflect something and then reflect it back, do the inverse, you wind up with the same thing that you start with the original figure. Now we will do the examples, the exercises 1 to 3 in your classwork for lesson 8. Please stop the video and look for the exercises 1 to 3 in lesson 8 in your math binder. So you're working on problems S4 on page S40 and S41. Okay, after having done those 3 problems, let's go over them. So we have on this page a figure A, and we have a picture of figure A translated, and then we have a picture of the reflection of figure A after it's reflected. And we have 2 vectors, VA and line segment DC. So number 1 says figure A was translated along vector VA, resulting in the translation of figure A. Describe a you could have called that figure A prime or A prime. Describe a sequence of translations that would map figure A back onto its original position. So if we start with figure A and we translate it, we would have to translate it along vector VA. So we would follow the translation along VA and map it. And then we'd have to go back along the same vector, but in reverse. So we travel along vector AB this time. It's a subtle difference. So we would have to translate figure A along vector BA, then translate the image, let's call it A prime, along vector AB. Second question, figure A was reflected across line L, resulting in the reflection of figure A. Okay, we could call that a double prime since we already called the translation A prime. Describe a sequence of reflections that would map figure A back to its original position. Well, you start with figure A, and you reflect it across line L, so you would flip your transparency, I can't really do that here, and you would flip it over, and you would get the reflection of figure A, and then you would have to flip it back again. You should have tried that with your transparency. So you're going to reflect figure A across line L, and reflect the image of figure A, call that A double prime, across L again, line L again. And the last question says, can translation VA, so if we undo the transformation of translation DC, why or why not? So they're asking you, can you translate the figure along VA? So that would be in this direction. And then, can that undo the transformation of translation DC? So, let's try the translation along DC. Here's DC, and here's BA. Doesn't look like it's undoing it. So you should be trying that with your transparency. You should try the translation of figure A along line segment DC, and then try the translation of that figure along BA. Can it be undone? It should be obvious that no, it cannot be undone. To undo the transformation, you would need to move the image of figure A after the translation back to figure A. And the listed translations do not do that. Okay? To undo the translation of DC, you would need to translate image along CD. Okay, let's look at this picture here. That's on the smart board. We're going to start with figure E, which we could call an ellipse. And we want to ask ourselves, does the order in which we sequence rigid motions really matter? So we just did a sequence of reflections. But now we'd like to try reflection followed by a translation and see what happens. Would the figure be in the same location as if we did a translation first and then a reflection? So here we have a reflection across line L, and T is the translation along vector AB, and E is an ellipse. So the following picture shows you a reflection of E. So it shows you the red circle being reflected across line L. What you could do is trace this line L and the ellipse E and vector AB and reflect it across line L. And you'll see that it will wind up here. You should try it because I think it's something that you may not think would wind up there after reflection, but it actually does. So I want you to try that. Draw line L, draw the ellipse E, reflect the ellipse across line L. Then translate it. Now draw the vector AB after you flip that red figure, ellipse E, and translate it. And it would wind up right here. So that's a reflection followed by a translation. Now let's see what happens if we do a different order. So we have the same picture. So we have line L, and we're going to do a translation of the ellipse first. So here we have figure E, and we're following it along this translation. So it slides down. It slides down. You'll see it better on your transparency, but E moves to the translation. And now flip your transparency over line L. Reflect it over line L, and it winds up here. So is the resultant image in both pictures the same? When you, in the first one, when you did a reflection and then a translation, the figure wound up down here. In the second one, when you did a translation followed by a reflection, the figure was here. So they are not in the same place. So it should be clear now that the order in which the rigid motions are performed does matter. In this case, it does matter. So therefore, a translation followed by a reflection and a reflection followed by a translation are not equal. You don't get the same result. So now I want you to watch the video. The link is on the calendar. It's a YouTube video which shows a video of a sequence of basic rigid motions. So pause the video, go back to the math calendar for today's date, and watch the YouTube video. Pause this and do that, and then come back to the video. So when watching the video, you should have discovered, or should have noticed, or it should have been reinforced to you what the idea is of sequencing, of doing reflection, rotation, translation, the order of those. Now you can pause the video and do the exercises 4 through 7. Those are the exercises on S42 and S43. You need your transparency. Okay, let's look at exercises 4 and 5. They both, in number 4, it says let there be a translation along vector AB and a reflection across line L. So you must have your transparency or page protector. It's essential. So you're going to use a transparency to perform the following sequence. You're going to do a translation of figure S, then reflect figure S and label it S prime. So I can do the translation along vector AB. So that's the first part of it, and it winds up over here. Now you're going to reflect this along this line of reflection, this line right here. So flip your transparency. It should wind up at the figure is about over here. And label it S prime. This is from number 4. Okay. Question number 5 says, let there be a translation along the vector and reflection across line L. Except this time you're going to reflect figure S and then translate the figure. So you're doing the order in reverse. So let's move this back. now what you're going to do is reflect it. So you're going to flip over your transparency across line L. I can't do that because it doesn't flip in the direction of line L. It only flips left or right or up or down. But your transparency, you should flip it over line L and then translate along AB. So after you flip it, draw your vector where it is, right here, and then you're going to translate it. So that figure should wind up somewhere down here. And this is S double prime. So this is number 5. So obviously, this shows that the order in which you do a reflection and translation does matter. You get a different result depending on the order. That's what these two examples are trying to show you. Now let's look at problem number 6. Okay, for problem number 6, you're going to actually create your own translation. So let's read the directions together. Using your transparency, show that under a sequence of any two translations, so that's translation and translation O, along different vectors. So the first one is along one vector, the second one is a translation along the second vector. That the sequence of the translation followed by the second translation is equal to the second translation followed by the first translation. In other words, draw a figure A, any figure you want, triangle, square, slice of pizza, and any two vectors. Show that the translation along the first vector, followed by a translation along the second vector, puts the figure in the same location as when you perform the translations in reverse order. So we know that from what we did before. You're just going to now prove it to yourself once again and reinforce it to yourself. Now you're going to draw two new vectors and translate them just as they did before. This time, label the transformed image A double prime. And compare your, you have no one to compare it to, but we'll discuss it in class the next day. So you want to make sure you have something for problem number 6 that we can discuss the next day. Was the statement that the sequence of the translation followed by the second translation is equal to the sequence of the second translation followed by the first translation true in all cases? Do you think it will always be true? Hopefully you're convinced that yes, it will always be true. Okay, number 7 says, does the same relationship you notice in exercise 6 hold true when you replace one of the translations with a reflection? That is the following statement true? A translation followed by a reflection is equal to a reflection followed by a translation. So now, take what you did before, take the figure you had before, and now draw a line of reflection. And do a reflection of that figure followed by a translation. Label the resultant A prime. Then do the translation followed by a reflection and label that A double prime. And you should see that the results in each case are different. So the answer should be no. The translation followed by a reflection would put a figure in a different location in the plane when compared to the same reflection followed by the same translation. So let's write that down. You can copy that in your notes. So this last problem, number 6 and 7, is showing you this is the lesson. Number 6 is telling you a translation followed by a translation. A different translation is the same as if you reverse the order of translations. The images, the resultant image is the same, but when you do a translation followed by a reflection, that result is going to be different than a reflection followed by a translation. Okay, and then let's just go to the summary. So we know that we can do a sequence of rigid motions. We have notation now related to the sequence of rigid motions, the A prime, the A double prime, A triple prime, we're going to do 3 of them. We know that a reflection is its own inverse. You get that if you reflect on a line, you get that same line. We know that the order in which we sequence rigid motions does matter. Okay, this concludes lesson 8 and